this is Ria Bise, and today I'm going to give you a brief about the topic exception handling in Java. Exception handling in Java manages the control flow during the runtime errors. It prevents abrupt program termination and enhances the robustness of application. This presentation will cover essential concepts and best practices related to the exception handling in Java. Now, what are exceptions? Exceptions can be anything like disruptive events, error origins, or object representations. When we talk about disruptive events, exceptions are the events that disrupt the normal flow of the program. They signal unusual or anomalous conditions into the program and disrupt the execution or stop the execution of the program. Error origins. They are often caused by errors such as invalid user input or resource unavailability. These issues also prevent the normal operation or flow of the program and make it hard for execution. Object representation. In Java, exceptions are represented as objects. This allows for detailed information about the error which can be handled easily. Now, how do we handle the exceptions? Using the try, catch, finally blocks. Now, try block. Try block encloses the code that might throw an exception. That is, this is the place where the risky code is placed, which can raise an exception. Catch block. Catch block handles the specific exception types and executes when the exception occurs in the try blocks. Catch block is used for handling. Try block has the risky code which gives you the error, and that error is handled by the catch block. We have to specify what type of error the try block can give you so that it doesn't put the load on the JVM for searching numerous errors that are there in the JVM. So the catch block handles the exception and does not disrupt the flow of the program. Finally block. Finally block executes regardless of exception status. If there's an exception, also it uh, executes. If there's no exception, also it executes. It ensures that cleanup operation always run, that is cleaning the resources or release of the resources. Now, there are various type of exceptions. It can be uh, differentiated into two types: exceptions and errors. Exceptions then have two types: checked and unchecked exceptions. Checked exceptions are the compile time exceptions. The compiler forces you to handle them. For example, IO exceptions. Unchecked exceptions. Unchecked exceptions are the runtime exceptions. They are typically the indication of the programming errors. That is, there is an error into your program and you have to fix it. For example, null pointer exceptions, errors. Now, what are errors? These are irrecoverable problems. These are often at system level issues which cannot be handled by the developer or the programmer. For example, out of memory error. Throwing exceptions. Now, it is a particular method of indicating that your code has an error to the JVM and also to the programmers and developers. Using throw keyword, uh, exception is thrown and throws new exceptions object. Throw keywords creates an object and throws keywords indicates the JVM that this type of exception is thrown by the program or the developer. Custom exceptions. Developing custom exceptions is also available or a plus point of Java. We can uh, make our own custom exceptions, create them, and handle the code. And this is for specific application scenarios, which improves your code clarity. Method signature. Method signatures must declare through exceptions. This is to inform the callers about the errors that are going to be thrown or that are going to arise in the code. Best practices. Now, what is really important while doing exception handling and while using try catch and throws. Specific catch. Now, using specific catch block, that is giving the a catch block a specific type of error that is going to be arise, makes it easier for code execution and does not load your JVM so much, since the JVM has numerous exception types in which it handles various exceptions. So if you give a single type of exception or the specific exception type to the catch block, then it is easy for the JVM to directly go to the specific uh, you know noted ones and use them. Or else, what the JVM does is, if there is an exception and we give a normal type, then it goes to every type of exception, checks it, and then gives you the appropriate one, which is really irrelevant and is time consuming. It also does not give the effectiveness to the code. Next is log exceptions. Log exceptions are usually used for debugging. This is for monitoring and resolving the issue. Like if you want to test or debug a issue in a specific part of code, then we use the log exceptions, which help you debug the particular part of code, not the whole huge project or program. Appropriate level. Exceptions are supposed to be handled at appropriate level, and important error suppression is to be avoided. Many of the time, uh, the developers or the application developers suppress the important errors which give a long term impact into the application, not the code. Therefore, handling the exceptions at appropriate level enhances your code significantly. Cleanup resources. Resource cleanup in the finally block is really essential. Sometimes you might think that it executes even if there's exception, it executes even if there's no exception, but it is essential to clean the resources up and release them to prevent the resource leak, which is crucial in Java. Advanced concepts. Try with resources enables automatic resource management. That is, resources are closed automatically, and the work of the programmer, the code, and the JVM is done within a less time. Multiple catch block. There are high chances that a single try block can give you numerous type of exceptions. So these exceptions can be handled by multiple catch blocks, since each catch block addresses a specific type of exceptions. There can be multiple exceptions handling using multiple catch blocks and a single try block. Now it is custom exception classes. Extending the exception or runtime exception class, we can create a specialized exception classes which can be used for debugging purposes and which makes the code easier to run, execute, and understand. Conclusion. uh, Exception handling is really important for robust handling, which enhances the application quality significantly. Understanding the types, it is crucial for effective error management, which will keep the health of your application very proper to the long term, since there are going to be numerous users who are going to use the application. Maintainability, key for long term application health, as I said. Thank you.